In 5 seconds, a medieval iron clock morphs into a glitching computer terminal. It is tempting to assume this process is automatic, the result of a simple prompt typed into a void. Creating high-quality, culturally resonant visuals actually requires the intersection of historical research, aesthetic engineering, and physics-breaking computation. To see how this works, we are examining the Chronoglitch Manifesto, an experimental project designed to visualize the entire history of timekeeping. We are going to dismantle that 5-second clip to reverse engineer the underlying art, the complex math, and the physical resources required. Structured prompts provide the blueprint, breaking instructions into specific parameters: objects, action, style, camera, and atmosphere. The style parameter avoids documentary realism, instead utilizing an aesthetic triad of late 20th century media art. The first pillar is Stan Bergage, a 1960s experimental filmmaker who used material techniques like scratching and painting on film to introduce deliberate distortions. The second is Nam June Paik, who used analog signal distortions and feedback loops on CRT monitors to create early electronic glitch aesthetics. Prompts apply these modern styles to ancient history by forcing the AI to interpret the rock textures of the Lascaux caves through the lens of Bergage's material film grain. This aesthetic engineering remixes ancient artifacts through retro technology, giving the generated video its distinct character. Beneath the text prompt, the generation engine operates through massive-scale linear algebra. Models use matrices and tensors, large grids of data, and billions of learned weights called parameters. Stable Diffusion 3 uses 8 billion parameters. Through iterative refinement, the model starts with random noise, applying mathematical transformations until pixels converge into a coherent image. Generating a sequence of frames for video requires multiplying these operations by the frame count, meaning the mathematical workload scales linearly and rapidly. Producing 5 seconds of video at 30 frames per second demands approximately 7.5 trillion floating-point operations. A floating-point operation is a single calculation involving decimal numbers. Executing trillions of operations pushes silicon processors to their physical limits. State-of-the-art chips like the NVIDIA H100 handle a billion operations per second, yet video generation still consumes a large fraction of that throughput. The scale of this math is most apparent in its physical energy footprint. This chart shows that a 5-second video requires about 3.4 million joules of energy, 700 times more than a single high-quality image. Rendering those 5 seconds consumes the same amount of energy as running a household microwave oven at full power for over an hour. Reassembling these layers, the historical prompt, the 8 billion parameters, and the trillions of calculations, returns us to the final loop. AI video generation is a resource-intensive medium where cutting-edge physics processes ancient history. The Chronoglitch Manifesto treats digital artifacts like archaeological erosion. By celebrating bit rot and fragmentation, the project frames the digital glitch as a representation of human memory, incomplete, compressed, and distorted over time. Every 5-second loop represents billions of calculations and megajoules of electricity, actively restaging the past for the future.